That's alright, though, as there were plenty of other space stories to make scientists scratch their heads in puzzlement or scream with excitement. We've made a few discoveries, solved a few mysteries, and corrected a few mistakes. Now it's time to take a look back at some of the biggest breakthroughs of 2017. 10. Uncovering a mooncave suitable for a lunar base. The main reason why scientists are excited about this new discovery is that they feel lava tubes would make ideal candidates for future lunar bases. They are thermally stable, which would protect astronauts from the extreme temperatures on the surface, which range from 153 to 107 degrees Celsius, 243 to 225 degrees Fahrenheit. Furthermore, the underground tubes would also shield colonists and their instruments from cosmic rays and micrometeorites. Currently, only one model used for the formation of large bodies in the young solar system could account for this composition, the solar nebula model. As per this line of thinking, the dust pebbles were initially formed in the solar nebula and constantly combined through collision to form a larger body with an increased gravitational attraction. It took almost 6 centuries, but scientists finally found the source of this odd phenomenon. According to a team led by Dr. Michael Shara of the American Museum of Natural History, the mysterious star is part of a cataclysmic variable. After a few weeks, the nova faded away, and the new star disappeared once again. More importantly, Shara believes the discovery validates the hypothesis of his, stating that two types of binary stars are actually two stages of the same type of star. According to him, the nova-like binary star, which typically consists of a white dwarf and a red dwarf, eventually cools down and becomes a dwarf nova. 7. Determining the chances for life on Enceladus. A study published in the journal Science indicates that the same kind of chemical reactions which are responsible for sustaining life on Earth near deep-sea hydrothermal vents could also be happening in the subsurface ocean of Saturn's moon, Enceladus. This conclusion comes as the result of a 2015 flyby of the Cassini probe, which passed through an ice plume and detected molecular hydrogen, H2, using its onboard mass spectrometer. The team behind the study opines that the H2 is most likely being produced continuously by reactions between hot water and rock in and around the moon's core. This is backed up by an earlier 2016 study, which found that silica grains detected by Cassini on Enceladus were likely produced in hot water at significant depths. On Earth, microbes in deep-sea hydrothermal vents engage in a primitive metabolic process called methanogenesis. Cassini's measurements suggest that Enceladus's ocean has the resources necessary to sustain this action. However, researchers stress that these new findings do not suggest a detection of life, but rather an increase in habitability. Enceladus has become one of the main targets for potential extraterrestrial life ever since we found out it has underground water in 2005. Both private and government space agencies are considering missions in the 2020s to send probes equipped with life detection equipment through the moon's geyser eruptions. 6. Finding the truth behind the weird signal. Back in 1977, astronomers at Ohio State University were casually monitoring the skies for extraterrestrial intelligence when they picked up an anomalous radio transmission which appeared to be alien in origin. This year, we had the weird signal. Researchers first picked up this strange transmission on May 12 at the Arecibo Observatory in Puerto Rico. The source appeared to be Ross 128, a red dwarf star with no known planets located 11 light-years away from Earth. For 10 minutes, the signal was observed to be almost periodic, after which it disappeared forever. Obviously, when the announcement was made, the first reaction of many people was to think of aliens. However, while admitting that the signals were very peculiar, the Arecibo team opined that they were more likely the result of radio interference from human satellites or a stellar flare. Subsequently, a joint effort between the Puerto Rican astronomers and multiple SETI institutions confirmed that the weird signal came from geostationary satellites orbiting the Earth. That wasn't the last we heard of Ross 128, though. In November, astronomers announced that the red dwarf does actually have a planet orbiting it. Not only that, but it's an Earth-like planet with a slow rotation, and at a distance of 11 light-years, it is the second closest candidate for alien life outside our solar system. It's also got an advantage over Proxima Centauri b, the closest exoplanet, because it orbits a much less volatile red dwarf, which doesn't emit as many radiation bursts that could potentially destroy its atmosphere. 5. Observing two neutron stars colliding. Representing the collapsed cores of giant stars gone supernova, neutron stars are a rare and mysterious sight. This year, we had a front-row seat to an even rarer event, the collision of two neutron stars. Both the LIGO and Virgo detectors operated during the merger and observed, for the first time ever, both light and gravitational waves from a single cosmic event. Dozens of other telescopes were aimed at the collision, and the resulting data helped us elucidate an impressive number of astrophysical and astronomical conundrums. For starters, we confirmed that a merger between two neutron stars, called a kilonova, will produce a short gamma-ray burst, GRB. Moreover, the Fermi Space Telescope showed that, as predicted, gravitational waves travel at the speed of light or incredibly close to it. NASA's Spitzer telescope captured the longest wavelength infrared light resulting from the event, which showed the forging of gold, asserting that kilonovas are the main source of heavy elements which can't form in supernovas. And of course, this kind of scarce event is bound to raise some questions, not just answer them. Astronomers described the short gamma-ray burst as odd. Although it had the brightness of a typical burst, it was, in fact, less than 1/10 as far away as any other recorded GRB. More revelations and speculations will come as scientists unravel the data provided by this unique event. Back in 2015, the announcement of flowing, liquid water found on Mars became one of the biggest headlines of the year. However, new research suggests that the announcement was erroneous, as the flows were probably made of sand, not water. Since their first observation, these Martian features, called recurring slope lineae (RSL), have been found in over 50 areas. Only seeping water does this on Earth, so we thought the same applied to Mars. Specifically, Scientists argue that Martian RSL are only found on slopes deeper than 27 degrees, where the angle of repose matches that of Earth's sand dunes. If they consisted of flowing water, they should have extended to shallower slopes. The matter is far from settled. Flowing sand cannot completely account for certain traits of RSL, such as the seasonal appearance, gradual growth, presence of hydrated salts, and their rapid fading when inactive. Some experts believe that RSL could form through a mechanism unique to Mars, which would require on-site investigation to fully understand. 3. Determining the fate of the zombie star. Back in September 2014, the automated wide-field survey known as the Palomar Transient Factory (PTF) discovered a new star. It was supposed to be a run-of-the-mill star, so it was given the unremarkable name IPTF-14HLS. Even when it exploded, it still looked like a standard Type 2P supernova, which would have faded away after 100 days or so. And it did. At first, however, within a few months, the star inexplicably started to grow brighter. From then until now, IPTF-14HLS has fluctuated between dim and bright at least 5 times. Once astronomers realized they had an unusual star on their hands, they went through the archive and found something even more surprising. Another supernova was detected in the exact same location in 1954. It would appear that the star went supernova, survived for 60 years, and then did it again. It could be what some people have dubbed a zombie star. One idea put forward claims that the star is the first confirmed example of a pulsational pair instability supernova, a star so massive and hot that it generates antimatter in its core. This would make it incredibly unstable and lead to repeated eruptions before a final explosion and collapse into a black hole. Not everyone is on board with this theory, arguing that it doesn't line up with all the facts. Astronomer Andy Howell says such explosions were only expected during the early universe and compares it to finding a dinosaur alive today. To welcoming our first interstellar visitor. Earlier this year, we discovered the first confirmed interstellar visitor to pass through our solar system. The reddish, cigar-shaped interloper was first thought to be a comet, although closer inspection using the Very Large Telescope (VLT) revealed the lack of a coma. Subsequently, it was reclassified as an asteroid and given the Hawaiian name Oumuamua, meaning a messenger from afar arriving first. The rocky object is highly elongated, measuring over 400 meters, 1,300 feet, long but less than 40 meters, 130 feet, wide, which is an aspect ratio not seen in any other comet or asteroid observed in the solar system. Oumuamua also varies in brightness by a factor of 10 as it spins on its axis every 7.3 hours, which, again, is not a phenomenon we have ever observed in other rocky celestial bodies from our galactic neighborhood. Our current best guess suggests that Oumuamua came from the direction of the star Vega from the constellation Lyra, although the journey took so long that the star was not actually near that position at the same time as the asteroid. Although Oumuamua is a first, Astronomers remain hopeful that more interstellar objects will be found thanks to new, powerful survey telescopes like the Pan-STARRS. In the meantime, scientists are debating whether it is feasible or not to send a probe to the asteroid. Since the radiation can only be observed when the beam is pointing toward our planet, this creates the pulsing appearance of the emission. People have long speculated that pulsars can also be created from white dwarfs, and this year, we finally received confirmation. This is almost certainly due to interaction between the two stars, and scientists are now working on a model which can predict these long-term variations.